Okay, there's a couple more aspects of derivatives that I would like to illustrate with you and go over with you. And so keeping in mind that derivative is, of course, the slope, and that there are all kinds of applications as to how we can use that and different ways that we can ask that question. So you'll see here on the board that there's actually a couple different examples of questions, and you may want to write them down as just having those in front of you. And you may want to pause just so that you can write them down. That's, I guess, the advantage of having this recorded. So feel free to go ahead and write that down. But the first question reads, at what point does the slope of y equals 2x squared plus 2 equal to negative 2? In the past, the way we've asked the question is, I give you the equation and I give you the point and then ask you what the slope is. Now, instead of giving you the point, I'm giving you the slope and kind of working backwards. So hopefully at this point, you've had plenty of practice with using the slope so that you can easily see that we're talking about slope of this equation here, y equals 2x squared plus 2. And so my first order of business is to find its derivative, because I know that no matter what, the slope at any point is going to be its derivative. And I can just have a generic or a more generalized form of that. So to do the derivative, what would I do first? Great. We're going to drop that 2 down in front. So it's 2 times 2, which is 4x. We take away 1 from that power, so it's 4x. And what happens to the 2? Good. It goes away. So my derivative equation is 4x. I want to know, when will this equal 4x? So any guesses as to what you think I might do? Hopefully you're saying to yourself, hey, I could set that equation equal to negative 2 and figure out, when does that happen? When exactly will that occur? And of course, then it's pretty easy to see. What you're going to do is you're going to divide by 4 and solve for x. So I have x equals negative 1/2. But remember what this is saying. It says, what's the point? And so a point includes an x value and a y value. So how would I find the y? How do I find that y? Well, this says y equals. Notice I don't use the slope. I do not use the slope to find y. Instead, what I have to do is I go back to the original equation. I use this x, and I say, okay, y equals 2 times negative 1/2 squared plus 2. All right, negative 1/2 squared. And then I'm going to multiply through by the 2, so that gives me 1/2 plus 2. Common denominator is certainly helpful here, especially without those calculators, and you get 5/2. So what does that mean? That means that my point at which the slope is equal to negative 2 is negative 1/2, 5/2. And that would be the answer to that question. Great. Now the second question here says, given y equals x squared minus 4x plus 4, a little bit more advanced equation, find the point or points where the slope equals 12. Once again, we're not given the points, we're asked based on the slope. So I want to start by finding the derivative. Take a minute and find that derivative. When you think you've got it, look up ahead, see if you've got that answer. Hopefully you got 2x minus 4, to which we want to know, when does that equal 12? So once again, we're going to set that equal to 12. First step, add that 4, and then divide by 2. Again, we want to find that point or points where that is. Of course, we only have a point because we only have one x value. And so to find the y value that goes with this, again, we want to go into the equation that corresponds with y equals. The other one is the derivative, or y prime. So I'm going to plug 8 into this. So I have 64 minus 32, which is 32, plus 4 is 36. That means that the point is 836. And those are the only 2 pieces of new type questions that are going to be found on your homework assignment tonight. hopefully by now you're finding some great success. And if time allows today, we will actually be getting on the boards and working that way. So be watching for some more practice as we move through the slope and integral section.